Alright, in this video we're going to talk about some of the properties of exponents, and this should be review from Secondary Math 1, but always refer back to this if you need it. So there's a few different properties. The first one is what's called the product of powers. Now anytime you have the same base, notice A is the same, you take your two exponents, you add them together. So if I have 5 cubed times 5 to the 4th, that's 5 to the 3 plus 4, or 5 to the 7th. Okay, so just a quick example. You got 5 cubed, you got 5 to the 4ths, they're being multiplied, you got 7 5s. Okay, the next one is what's called power of powers. If you have an exponent being raised to an exponent, you take those two things and you multiply them together. Okay, so if I have 5 cubed squared, I take the 3 and the 2, I multiply those together, I get the 6, and I end up with 5 to the 6th. So I have 5 cubed, it's squared, so that means there's 2 of them. Now this goes back up to this property right here, 3 plus 3 is 6, it works out. The next one is what's called the power of product. Now in the power of product, if I have two things being multiplied with an exponent on the outside, what happens is it's similar to the distributive property, where that exponent gets sent through to both of them, and I end up with a to the m and b to the m. So here, the example I have is 6 squared. Well, 6 can be written as 2 times 3 squared, and you can see right there, that gives me 2 squared, 3 squared, and then you could solve it out. Now, negative exponents is the next one. Okay, if you have an exponent that's negative, what that does is it takes your base and it puts it in the denominator. Okay, so notice I have the 1 in top, that's my placeholder. It's saying it's now a fraction, and my term from here moves to the denominator, and the negative is gone. Okay, so over here I have 5 to the negative 2nd power. That 5 squared goes to the bottom, and which is the denominator, and that's why that negative is gone in that next step. So I end up with just 1 over 5 squared, which you could simplify to 1 over 25. Now for the 0 exponents, I have a to the 0 equals 1. Basically, with exponents, anything to the 0 power will always be 1, okay, as long as your a is not 0 itself. So here, I have 53 to the 0 power. Well, and no matter what it is, it's going to be 1, so there's your solution. Now, up above we had products, now we have quotients, which means we have division problems. So quotient of powers, I have a to the m over a to the n. Well, in this case, again, my base is the same, so I'm going to take my two exponents, and above, when I was multiplying, I added. Now that I'm subtracting, now that I'm dividing, I subtract. So I have a to the m minus n. So here I have 6 to the 4th over 6 squared equals 6 to the 4 minus 2, which is 6 squared. And the way to think of this, easy way, 6 to the 4th is 6 times 6 times 6 times 6. 6 squared is 6 times 6. Now anytime you have a fraction, if you have the same thing in the numerator and denominator, they cancel out. You're left with 6 times 6, which is 6 squared. All right, and then much like up above again, power of quotients, if I have something within a parenthesis that's being divided and an exponent on the outside, that exponent gets sent through. So I have a to the m over b to the m. My example here is 3/5 squared. So that means I have a 3 squared, I have a 5 squared, and I could simplify from there into 9 over 25, and there's your solution. All right, so let's try a couple of these. Evaluate. So I got 2 to the 5th squared. Now remember, I have a power raised to a power. That means that 5 and that 2 get multiplied. And this ends up being 2 to the 10th, which you could go further from there. And again, just to show why that happens, I have 2 to the 5th times 2 to the 5th because it's squared. And your 5 plus 5 is 10. It works out that way. In this second one, 11 to the 5th over 11 to the 8th. Okay, this is a division problem, and in division we subtract. So I have 11 to the 5 minus 8, which is negative 3. Now remember, a negative exponent moves this to the denominator. So the negative becomes a fraction. My 11 cubed moves to the denominator of that fraction, and I get 1 over 11 cubed, which again you could simplify further. Now the final two examples here bring in some of those distributive type properties that I talked about. So the x squared is by itself, it's good. Now this one has 3x squared inside with a 3 on the outside. That cube is going to be sent through. So step by step, I've still got that x squared. It's not equals, times. So I've got x squared times 3 cubed. Okay, so remember, this cubed goes over to the 3. So 3 cubed is 27. And I've got x squared cubed. Now again, because those things are power raised to a power, we're going to multiply and end up with x to the 6th. And then finally, I have x squared times x to the 6th. That's where we add the exponents because they're being multiplied together. So I've got x to the 8th, and then the 27 goes on there as well, and there's your final answer. Alright, so I want you guys to pause this video, take just a quick second, try D, and then come back and we'll look at it. Okay, hopefully you guys had a second to try that out. So this 3 is on the outside of my parentheses. I'm going to send it through to everything, and that's the key. So I have 2 cubed, which is 8. I've got 3 cubed, which is 27, and I've got a cubed, which is a cubed. So it's 8 over 27a cubed. There's your final answer. All right, give your assignment a try, and if you have questions, let me know.